Okay, I want to use this video to help you go over your homework on dimensional analysis, the factor label method, in case you're having a little trouble with dimensional analysis. This is on the back of the dimensional analysis card game that you had in class, and this is the paper that we're going over. We're going to do just a few problems. So feel free to pause the video as we go along and try a problem yourself and then watch some more. Okay, problem number 1 is 3 hours equals how many seconds? So I'm going to set up my fence post with my given over 1, 3 hours over 1, and then I need hours on the bottom to cancel, so I'm going to change it into minutes first. There are 60 minutes in 1 hour. That will let me cancel out the hours. That gives me minutes on top. I want minutes to cancel, so I put minutes on the bottom. And then I need seconds, so I'm going to put seconds on the top. See if this will help with the focusing. Sorry about that. And there are 60 seconds in 1 minute. Now I'm ready to do the math. 3 times 60 times 60 comes out to 10,800 seconds. I only want one significant figure because this is one sig fig, but this is exactly 60 minutes in an hour. This is exactly 60 seconds in a minute. So the only thing I have to worry about for sig figs is my given, which was 1. So for one significant figure, I'm going to round it to 10,000 seconds. Some of you might be bothered and say, well, what about our other 800 seconds? But please keep in mind that the 3 that we're given at the beginning is only an estimate. Right, number 2, 0.035 milligrams over 1. There are 10 milligrams in 1 centigram. This way milligrams cancels out, centigrams is left over, and 0.035 divided by 10 is 0.0035. That's 2 sig figs, and this is 2 sig figs, so I'm good to go. For number 3, a little bit different. We have 5.5 kilograms, and we're looking for how many pounds that is. You have on the back of your metric conversion some English to metric things, or you can Google this conversion and you'll find that 1 kilogram is 2.2046 pounds. I don't know if this is exact, but we'll count that as 5 significant figures. So 5.5 kilograms over 1. Need kilograms on the bottom to cancel. 1 kilogram. 2.2046 pounds on the top. Then 5.5 times 2.2046 is 12.1253. We only have 2 sig figs in the 5.5. We have 5 sig figs in this other number, so we're going to round it to 2. So this 1 won't make the 2 round up, so it just becomes 12 pounds. Alright, let's skip down to number 6, because that has scientific notation in it, and some people find that tricky. You're given 3 moles, and you want to know how many molecules that is. Now this is actually a real chemistry problem. You don't have to understand what moles are right now, because they tell you in the problem that 1 mole is equal to 6.02 times 10 to the 23rd molecules. That's given in the problem. So to say an MOL, by the way, is the actual abbreviation for MOLE. But let's set it up. 3 moles over 1. It's one of the reasons why I want you to learn this dimensional analysis fence post anyway, to do real chemistry problems with. Need moles on the bottom in order to cancel out, and 1 mole is 6.02 times 10 to the 23rd molecules. So it's just 3 times that number. Now on your calculator, I don't know if I have enough light for this to show up. Maybe if I do it this way. Okay, I'm going to do 3 times Okay, well watch what my fingers are doing. You can see it on your own screen. 6.02 second. See right here, the second button? And then above the 7, that little comma. See that little orange EE right there? That's what you want. So second, and it gives you an E. This terrible video, sorry. It gives you an E on your screen, which means times 10 to the, and then we're going to put in 23. And the answer is 1.806, my calculator says 1.806 E24. Okay, well the E is the times 10 to the, so it's really 1.806 times 10 to the 24. But 3 moles, remember, is only 1 sig fig, so I need only 1 in my answer. So I'm going to round it to 2. So 2 times 10 to the 24 molecules. Okay, and then let's do one more. Let's go down to number 10. On number 10, you're given 50 liters, 50 decimal, and then the liters, which means that's 2 significant figures. And this time we're looking for molecules. And besides the relationships that we already learned earlier about 1 mole is this many molecules, they also tell us in this problem that 1 mole is equal to 22.4 liters. Now that's for a gas if it's at standard temperature and pressure, but we'll pretend like we are and solve the problem. So 50 liters over 1. I need liters to cancel out, so I'm going to put that on the bottom. I'm going to need to go to moles first because then I can go from moles to molecules. So 22.4 liters on the bottom to 1 mole on top. Now sometimes you'll see me make these in boxes instead of little times thing. We'll do in a box and it means the same thing. And so now we need 1 mole on the bottom and 6.02 times 10 to the 23rd molecules on the top. And the math is we multiply the top and divide by the bottom. So I'm going to type in my calculator 50 times 6.02 second, comma, to get that EE, so that's times 10 to the 23rd, divided by 22.4. So, watch my fingers put that in. That's 50 times 6.02 second, right there, comma, to get the EE, 23. Notice I'm not using this up caret and I'm not putting in the times 10. I'm just doing 6.02 second, comma, 23. Okay, and I already did times 50. And now I need to do divide by 22.4. Enter. And my calculator says 1.34375 E24. So I'm looking to see, I have 2 sig figs here, that's 3, so I want 2 in my answer. So my answer is going to be 1.3 times 10 to the 24 molecules. And that's all there is. If I have time today, I'll record another one for going over the metrics and measurement page, but I don't know if I have time or not for that.